For over a century, astronomers were convinced a hidden world orbited near the Sun. This is the story of the planet Vulcan, a world that never was. By the end, you will understand how the search for a ghost planet reshaped our universe and gave birth to one of science fiction's greatest legends. We will unravel why brilliant minds were so certain it existed and how its ultimate failure led to a revolution in physics. What does it mean when our most trusted science is wrong? The 19th century universe was a masterpiece of order. Isaac Newton's laws of gravity described a perfect cosmic machine where every planet, moon, and comet moved along its path with mathematical precision, as predictable as the ticking of a grand celestial clock. Astronomers could calculate the position of Jupiter decades into the future or pinpoint the return of a comet with stunning accuracy. This was the power of Newtonian physics, a system so complete it seemed to leave no room for mystery. Yet, in this clockwork perfection, one tiny gear refused to turn quite right. The planet Mercury, the swiftest world orbiting closest to the Sun, had a slight but undeniable wobble in its motion. Its elliptical orbit itself was slowly rotating, a phenomenon called the precession of its perihelion. Think of drawing an oval on a piece of paper, but with each trip around, the point where Mercury comes closest to the Sun shifts forward just a tiny bit, causing the entire oval to slowly pivot. Most of this shift could be explained by the gravitational tug of the other planets, especially Venus and Jupiter. But a stubborn, minuscule portion of this precession remained unaccounted for. Every calculation, every adjustment for known gravity still left a tiny gap in the data. For a universe governed by perfect equations, this was an unacceptable flaw, a single discordant note in an otherwise harmonious symphony. Into this puzzle stepped a man who had already proven he could find new worlds with mathematics alone. Urbain Le Verrier was a French astronomer of formidable intellect, so brilliant he was often called the Newton of France. Just years earlier, he had faced a similar mystery with the planet Uranus, whose orbit was also deviating from predictions. Le Verrier did not build a bigger telescope. Instead, he took to his desk, performing months of intense calculations. He predicted that the gravitational pull of an unknown, more distant planet must be causing Uranus to stray. He sent his coordinates to the Berlin Observatory, and on the very night they looked, they found it, Neptune. Le Verrier had discovered a planet with nothing but pen, paper, and the unshakable laws of Newton. His triumph was monumental. It was proof that if the math said something was there, it must be. So, when he turned his attention to the nagging problem of Mercury's wobble, the scientific world held its breath. The precedent was set. If a planet could be found from an anomaly in Uranus's orbit, why not from an anomaly in Mercury's? The logic was irresistible. The celestial clockwork had a tiny, persistent error, and Le Verrier was the man who knew how to read it. The solution seemed elegant and for Le Verrier utterly inevitable. In 1859, he stood before the French Academy of Sciences and made his announcement. After months of painstaking calculation, he declared the mystery of Mercury's orbit was solved. The mathematics were clear. The only force that could account for that tiny, persistent wobble was the gravity of an unseen body, a planet orbiting even closer to the Sun than Mercury itself. He even entertained the possibility of not one planet, but a ring of smaller asteroids, a celestial debris field whose combined mass would create the same gravitational effect. But the core idea was a new world hiding in the Sun's blinding glare. He gave it a name that felt destined, Vulcan, for the Roman god of the forge of fire and metal. It was a perfect fit for a world imagined to be scorched by perpetual solar fury. The reaction across Europe and America was electric. Here was the man who had conjured Neptune from pure math, now pointing his finger at a new spot in the sky and saying, "Look there." The excitement was palpable. Telescopes were immediately trained on the region around the Sun. especially during solar eclipses when the sky darkened enough to potentially reveal a faint, fast-moving dot. Amateur astronomers joined the hunt, hoping to claim the glory of a visual discovery. Yet, woven through that excitement was a thread of profound skepticism. Some astronomers questioned the data itself. Was Mercury's anomalous motion even real, or was it an error in observation? Others wondered if Leverrier's calculations, while brilliant, had become a kind of trap. Having proven that math could find a planet once, was he now forcing the universe to fit his equations, seeing a pattern where only noise existed? The hunt for Vulcan became a scientific drama with the highest possible stakes. It was a test not just of a new planet but of the entire Newtonian framework. If Vulcan was found, it would be the ultimate triumph of predictive science, a second victory for calculation over observation. But if it was not found, what then? The unthinkable question began to whisper in the background. What if the flaw was not in the sky but in the law of gravity itself? The first reported sighting came not from a grand observatory, but from a country doctor. In a small French village, an amateur astronomer named Edmond Modeste Lescarbot spent his rare free moments observing the sun through a modest telescope, projecting its image onto a screen to study sunspots. On a March afternoon in 1859, he noticed something extraordinary. A tiny, perfectly round black dot was slowly creeping across the brilliant solar disk. He timed its transit, sketched its path, and with trembling hands wrote a letter to the most famous astronomer in France, Urbain Le Verrier. When Le Verrier received the letter, he did not dismiss it. He boarded a train and arrived unannounced at Lescarbot's door, interrogating the doctor like a scientific detective. He examined his notes, his telescope, even the wooden beam where he had marked the time with a nail. To the world's astonishment, Le Verrier declared the observation credible. He had found his witness. The verification by the man who discovered Neptune was all the confirmation the world needed. Vulcan was real. A celestial gold rush erupted overnight. If a country doctor could see it, so could anyone with a telescope and patience. Professional observatories began dedicated patrols of the sun's limb. Amateur astronomers across Europe and America turned their instruments skyward, hoping to be the next to catch the elusive world. Reports began to flood in. A respected observer in the United States saw a round object transit. Another in Germany noted a suspicious dot. Each new account, no matter how tentative, was breathlessly reported in newspapers and scientific journals, adding another piece to the puzzle of Vulcan's orbit. But this was the most difficult observation in all of astronomy. Staring at the sun, even indirectly, meant battling its overwhelming glare. The Earth's own atmosphere boiled and shimmered, distorting the view, turning steady sunspots into quivering blobs. In that chaotic, blinding brightness, the human mind desperately seeks patterns. Was that dark speck a new sunspot forming, a high-altitude bird passing miles overhead? Or was it, at long last, the planet Vulcan? The line between discovery and delusion became dangerously thin. Every observer wanted to see it, and in that wanting, the eye could easily betray the mind. The collective hope for Vulcan began to shape what people believed they saw, turning faint atmospheric ripples into a world that fulfilled a beautiful, logical prophecy. Yet the clockwork universe demanded precision, and Vulcan's schedule was anything but precise. Le Verrier, armed with the scattered sightings, calculated when the planet should next cross the face of the sun. These predicted transits were published for the world to see, turning specific dates into moments of high scientific drama. Astronomers across continents would ready their equipment, their eyes trained on the solar disk at the appointed hour. And time after time, nothing happened. The sun's face remained unblemished, save for its familiar, slowly shifting spots. The predicted world did not appear. These failures were more than simple disappointments. They were direct contradictions to the mathematical model Vulcan was supposed to confirm. If the planet was real and massive enough to tug on Mercury, its orbit should be calculable. Its silence during these critical windows spoke volumes. The sightings themselves began to unravel under scrutiny. One observer would report a transit lasting an hour, another would see a similar dot for only 20 minutes on the same day. The object's reported size and speed varied wildly. Some accounts placed its path directly across the sun's center, others had it skimming the edge. This was not the consistent behavior of a solid, orbiting body. It was the chaotic signature of illusion. The scientific community, once united in hopeful pursuit, began to fracture. A growing chorus of skeptics argued that every supposed observation could be explained by something else: a sunspot group breaking up, a fleck of dust on a telescope lens, or simply the human eye straining against a sea of light. Among the most influential doubters was the American astronomer Simon Newcomb. A master of celestial mechanics himself, Newcomb approached the Vulcan problem with cold, meticulous logic. He gathered every reported sighting and subjected them to brutal statistical analysis. His conclusion was damning. The data was a mess. The observations showed no consistent orbital pattern. They were random, clustered around times of particular public excitement or following Leverrier's new predictions. It was not evidence of a planet, Newcomb argued, but evidence of the powerful human desire to see one. The Great Vulcan Hunt, he suggested, had become a case study in collective self-deception, where the prestige of the predictor and the allure of the story had overruled the strict standards of proof. The ghost planet was fading, not from the sky, but from the realm of credible science, leaving behind an even deeper and more troubling mystery. If Vulcan was not there, then what on Earth, or rather, what in heaven, was causing Mercury to dance? The tension demanded a final, decisive test. If Vulcan was real, there was one event that could reveal it beyond all doubt: a total solar eclipse. During those brief, magical minutes when the moon completely blocks the sun's brilliant face, the sky darkens to twilight and the stars come out. Any planet hiding in the sun's inner sanctum would suddenly become visible, a faint pinprick of light against the deep velvet of the eclipsed sky. The astronomical community pinned its hopes on the eclipse of July 29, 1878, its path of totality stretching across the rugged American West. This would be the courtroom, and the evidence would be photographic. Expeditions were mounted with military precision, funded by universities and governments, racing to remote locations in Wyoming and Colorado. They hauled tons of delicate equipment, telescopes, and early cameras over rough terrain by rail and wagon, all for a celestial event that would last less than 3 minutes. Among them was a team led by James Craig Watson, a highly respected astronomer and director of the University of Michigan's Observatory. Watson was a true believer, convinced that Leverrier's math was infallible and that Vulcan was waiting to be seen. He set up his station at a site in Wyoming, carefully aligning his instruments, knowing the entire scientific world was watching. As the moon's shadow swept across the plains and the last sliver of sunlight vanished, Watson peered through his telescope into the sudden darkness. There, nestled in the corona's eerie glow, he saw them. Not one, but 2 small, star-like points close to the sun where no known stars should be. His heart must have raced. He called over his assistants, who confirmed the sightings. In his meticulous notes, Watson recorded the positions of what he believed were 2 intramercurial planets, with one likely being the fabled Vulcan itself. When the news broke, it sent a shockwave through the international community. Here was not an amateur's sketch, but the sworn testimony of a premier professional, made under ideal conditions during the ultimate astronomical test. Newspapers declared the mystery solved. For a fleeting moment, it seemed the celestial clockwork was saved. Vulcan had been found, and Newton's universe, with Leverrier as its chief engineer, stood triumphant. This was the high watermark, the moment of apparent validation that turned a decades-long ghost story into accepted fact. But science, in its relentless pursuit of truth, has a way of scrutinizing even its most cherished victories. Yet the triumph of 1878 was built on sand. In the cold, analytical light that followed the eclipse, Watson's observations began to crumble. Other astronomers who had been stationed along the path of totality, equipped with similar instruments and the same fervent hope, had seen nothing. No mysterious points of light, no new worlds. They had photographed the eclipsed sun and its corona, and their plates showed only the expected stars, their positions meticulously charted for over a century. When the scientific community compared notes and, crucially, the photographic evidence, a harsh reality set in. The stars Watson had seen and recorded were just that, ordinary stars. They were already catalogued, their positions known. In the adrenaline-fueled rush of those precious 2 minutes of darkness, in his powerful desire to see what the equations demanded, Watson had misidentified them. His Vulcan was a celestial mirage, the most convincing one yet, but a mirage all the same. This was the turning point. The definitive test had failed. After this, the long silence truly began. No credible, verifiable sightings emerged. The occasional report from an amateur would surface, only to be swiftly dismissed by professionals who had grown weary of the phantom. More importantly, technology itself began to argue against Vulcan's existence. Telescopes grew larger and more precise. The new science of astrophysics, with spectroscopes that could analyze the light from celestial objects, offered another tool. If Vulcan was a rocky planet close to the sun, it would reflect sunlight in a specific way. Astronomers began sweeping the regions around the sun, not just during eclipses but at dawn and dusk, using these advanced instruments to search for any spectral signature of a solid, orbiting body. They found nothing. The space where Vulcan was supposed to be was empty, save for the solar wind and the faint zodiacal light from cosmic dust. Without a single piece of new evidence, the astronomical community had no choice but to move on. The vibrant, decades-long hunt gradually lost its energy. Textbooks quietly updated their solar system diagrams, removing the speculative dot inside Mercury's orbit. The name Vulcan began its migration from the astronomy journals to the history books, a fascinating footnote in the story of human error. It became a cautionary tale, taught to young scientists about the dangers of confirmation bias, about the seductive power of a beautiful theory in the face of stubborn facts. But the core mystery remained, now more profound and unsettling than ever. If the greatest observational search of the age, bolstered by the most brilliant mathematics of the era, could not find the cause of Mercury's wobble, then the problem was not in the sky. The problem had to be in the foundation. The clockwork universe, for all its majestic precision, had a crack in its very gears, and a young patent clerk in Switzerland was about to take a hammer to it. The crack in Newton's celestial clockwork could no longer be ignored. For decades, astronomers had tried to fill it with a phantom planet, patching the gears with an invisible world. But the solution was not to add another piece to the machine. It was to realize the machine itself was an incomplete model. The man who saw this was not an astronomer scanning the skies, but a theoretical physicist in a quiet office, reimagining the very fabric of reality. Albert Einstein had already shaken the world with his special theory of relativity, which wove space and time into a single continuum. But it was his general theory of relativity, published in 1915, that offered a breathtakingly new vision of gravity itself. In Einstein's universe, gravity is not a mysterious force reaching out across empty space, as Newton described. Instead, think of the cosmos as a vast, taut rubber sheet. Place a heavy bowling ball in the center, and it creates a deep, smooth depression. That bowling ball is the sun. Now roll a marble along the curved surface of that sheet. The marble will not travel in a straight line. It will curve inward, tracing an orbit around the central depression. The marble is Mercury. In this picture, the planet is not being pulled by a force. It is simply following the straightest possible path through a universe where space itself is warped by mass. This curvature is what we feel as gravity. The sun's immense mass creates a profound well in the spacetime around it, and every planet, comet, and speck of dust moves along the contours of that invisible geometry. For Mercury, the planet deepest within the Sun's gravitational well, this curvature has a unique effect. As it travels its elliptical path, the planet is not just going around the Sun, it is navigating the steepest slopes of this spacetime valley. The orbit itself slowly rotates, its point of closest approach shifting forward with each trip. This is the precession that had baffled astronomers for generations. When Einstein completed his field equations, he turned them toward this oldest of astronomical puzzles. He did not introduce a new planet or tweak an old constant. He simply applied his new description of gravity to Mercury's motion. The calculation was elegant and stunningly precise. His equations predicted an extra advance in Mercury's perihelion of exactly 43 arcseconds per century. Not approximately, not within a margin of error, but exactly the amount that had stubbornly refused to be explained by Newtonian physics and the gravity of all other known planets. It was a perfect match. In that moment, the ghost of Vulcan was not merely disproven, it was made utterly unnecessary. The anomaly was not a missing world, it was a signature, a tiny but precise fingerprint left by the curvature of spacetime itself. Mercury's wobble was not a problem to be solved by adding more pieces to the old model. It was the first observational proof that the model itself needed to be replaced. Einstein reportedly said that seeing this result gave him heart palpitations, that for days he was beside himself with joyous excitement. He had not found a new planet, he had discovered a new universe. The true legacy of Vulcan is not a world but a revolution. For decades, this phantom planet was the only acceptable solution within a perfect, closed system. Its very pursuit, this grand collective effort to find something that wasn't there, performed a vital service for science. It forced astronomers to sharpen their tools to a razor's edge. The hunt demanded unprecedented precision in measuring planetary positions, in timing transits, in calibrating telescopes and photographic plates. Every reported sighting was subjected to brutal public scrutiny, establishing new standards for what constituted proof. The debate over Vulcan was a masterclass in scientific skepticism, a slow, grinding process where hope was systematically weighed against evidence. In this way, the failed search acted like an immense pressure cooker, testing the limits of the Newtonian model until finally its flaw could no longer be ignored. Mercury's tiny wobble became a pristine laboratory, a single, unsolvable puzzle that sat in plain sight for generations. It was the one gear that would not mesh, the one note that would not harmonize. And because brilliant minds had exhausted every conventional fix, planets, asteroid belts, observational error, the anomaly stood alone, isolated and glaring. This clean failure was the gift. It presented Einstein with a perfect test, a precise numerical discrepancy that any new theory of gravity would have to explain exactly. Without Vulcan's long shadow, without that decades-long process of elimination, Mercury's odd behavior might have remained a minor, nagging curiosity. Instead, it became the keystone evidence that shattered an old universe and ushered in a new one. The ghost planet, by its profound absence, cleared the stage for a radical new actor, the curvature of spacetime itself. So the story of the planet Vulcan ends with a revolution in physics, but the space inside Mercury's orbit did not simply become a cosmic dead zone. The ghost of the idea was reborn in a new, more modest form. Astronomers today still ask if anything could survive in that scorching inner sanctum. Not a full-sized world, but a swarm of tiny survivors. They call them the Vulcanoids. This modern hypothesis suggests that a belt of small asteroids or ancient planetesimals, perhaps no larger than mountains or even city blocks, might still cling to stable orbits between the Sun and Mercury. These would be the last remnants of the early solar system, rocky bodies that somehow avoided being flung outward, consumed by the Sun, or smashed into Mercury itself over billions of years. Finding them, however, is a challenge that makes the 19th century search look simple. You are trying to spot a dark, faint speck of rock that is perpetually lost in the sun's blinding glare, a search conducted in a sky that is never truly dark. Ground-based telescopes are almost useless for this task. The solution came from looking at the sun not as an obstacle, but as a backdrop. Space-based solar observatories like the Solar and Heliospheric Observatory, or SOHO, have provided a unique vantage point. These instruments are designed to stare continuously at the sun, monitoring solar storms and the corona. But in their data, scientists can search for something else, tiny black dots that might drift across the solar disk. Think of it as looking for a single grain of black sand slowly rolling across the face of a brilliant searchlight. The technical hurdles are immense. Any candidate object would be incredibly faint and moving quickly. It could easily be confused with a cosmic ray hitting the detector, a piece of orbiting space debris, or a glitch in the electronics. Despite decades of searching with increasingly sophisticated tools, no confirmed volcanoid has ever been found. Each non-detection further constrains what could possibly be there. If a belt exists, it must be incredibly sparse, a few lonely rocks in a vast and hostile volume of space. Yet the search continues, not out of stubborn belief in an old myth, but because finding even one volcanoid would be a scientific treasure. These objects would be time capsules from the very dawn of our planetary system, orbiting in a region where conditions have been too harsh for the geological processes that reshape planets. They could tell us secrets about the original building blocks of the inner solar system, untouched for 4.5 billion years. So the legacy of Leveria's world lives on, not as a planetary failure, but as a persistent question that pushes our technology and our curiosity to their absolute limits. While astronomers were quietly retiring the name from their star charts, a different kind of creator was giving it new life. The planet Vulcan, having failed as a scientific reality, found a vibrant and enduring afterlife in the realm of imagination. Almost as soon as it vanished from the telescopes, it began to appear on the covers of pulp magazines and in the panels of comic books. The name itself was a gift to storytellers, carrying an immediate and powerful resonance. Vulcan, the Roman god of fire and the forge, suggested a world of primal heat and industry, a place of both creation and destruction. Writers of the 1930s, 40s, and 50s eagerly adopted this ready-made mythology. They took the astronomical premise, a world orbiting perilously close to a star, and extrapolated it into landscapes of breathtaking extremity. In these early stories, Vulcan was rarely a welcoming place. It was a dying world, its ancient civilizations crumbling under a relentless red sun. It was a desert planet of endless dunes, where the very air shimmered with heat haze and strange creatures lurked in deep canyons. Often, it was portrayed as a source of malevolent power or ancient, forgotten technology, a trope that played directly into Cold War anxieties about lost superweapons. The name evoked the infernal, a hellscape just next door in the cosmic neighborhood. For readers, it required no elaborate explanation. Simply calling a planet Vulcan instantly set the scene, a shorthand for exotic danger and ancient mystery. This was a direct inheritance from its scientific past. The very fact that real astronomers had believed in it lent the fictional world a veneer of plausibility, a foot in the door of the possible. In one notable 1932 science fiction novel, the protagonist journeys to a Vulcan described as a world of metallic seas and crystalline mountains, a vision that feels like a literal interpretation of a volcanic forge. Another serial from the 1950s featured a Vulcan that was the last refuge of a telepathic race, hiding its mental powers from a galaxy of hostile, non-psychic beings. These early iterations cemented the name in the popular lexicon, forever linking it to themes of antiquity, alien wisdom, and environmental harshness. The ghost planet, it seemed, was far too compelling an idea to simply fade away. It had to live somewhere, and if not in our solar system, then it would thrive in the endless space of our stories, waiting for its most famous incarnation to finally give it a face and a pointed ear. But the name's journey into immortality required one final, perfect alignment. In 1966, a television producer named Gene Roddenberry was building a universe from scratch. He had a starship, a diverse crew, and a vision for a future where humanity explored the stars. He also had a character, an alien science officer with pointed ears and a demeanor of cool rationality. This character needed a home, a world that would explain his culture, his logic, his very being. Roddenberry scanned the stars for a name, and his eyes fell on a fascinating footnote in an astronomy book, Vulcan. The choice was a masterstroke. It was not arbitrary. The name carried exactly the right weight. Scientifically, it came from a real astronomical hypothesis, which gave it an instant air of credibility and intelligence. It connected his fictional universe to our own history of cosmic inquiry. Thematically, it was perfect. The Roman god Vulcan worked at a forge, using fire and logic to shape raw materials into precise, functional tools. What better metaphor for a society that prized logic above all else? A culture that forged its emotions into a disciplined, rational framework. And there was that lingering mystery, the ghost planet that was never there. This added a layer of profound depth. The Vulcans of Star Trek were not just logical, they were survivors. Roddenberry and his writers would later develop a rich backstory of a species once torn by violent emotion who, facing extinction, embraced logic as their salvation. They became a people who had mastered their inner chaos, just as the scientific community had to master the chaotic, false promise of the phantom planet. In a single, inspired decision, Roddenberry performed alchemy. He took the residue of a scientific error, the dust of a discarded hypothesis, and transformed it into narrative gold. He repurposed the name completely, severing it from its failed astronomical past and welding it to a new, powerful set of ideas. Vulcan was no longer a missing rock, it was the birthplace of a philosophy. It became a symbol of enlightened self-control, of a civilization that looked to science and reason as its guiding lights. Mr. Spock, half human and half Vulcan, embodied the eternal tension between those two ideals, making the name resonate with millions. Through him, Vulcan entered the global consciousness, forever changing what we hear when that word is spoken. The ghost was finally given a body, a history, and a soul, becoming one of the most iconic and beloved locations in all of fiction. So what kind of world did Roddenberry and his writers forge from this name? The planet Vulcan, as depicted in Star Trek canon, is a masterpiece of thoughtful world-building, where every environmental detail serves to explain the culture it produced. It orbits the star 40 Eridani A, a real star system astronomers have noted could potentially host habitable worlds. Vulcan itself, however, is far from a gentle paradise. It is a harsh desert planet, a landscape of sprawling crimson dunes, jagged mountain ranges, and ancient weathered rock. Its atmosphere is thin, its skies are perpetual, dusty ochre red. This is not a world of lush forests and blue oceans. It is a place of scarcity and relentless solar radiation, a global forge where survival itself demanded discipline. The planet possesses a gravity slightly higher than Earth's, giving Vulcans their noted strength and deliberate, measured movements. Perhaps most strikingly, Vulcan has no moon. Its night sky is a deep, star-filled blackness, uninterrupted by a gentle lunar companion. This single fact carries profound implications for a developing culture. Without a moon, there are no significant tides to shape coastlines or drive biological rhythms. The world is geologically quieter, its climate more starkly defined by the direct, unfiltered relationship between the land and its sun. These were not random choices. The writers, often consulting with scientists like the renowned astrophysicist Dr. Sagan, wove semi-plausible justifications into the fabric of the world. The red sky, for instance, could logically be explained by fine iron oxide dust, similar to rust, suspended high in the thin atmosphere, scattering sunlight to create that perpetual sunset hue. The high gravity fit with planetary formation models for a rocky world of certain size and density. The lack of a moon provided a clean, elegant reason for the planet's stable axial tilt, and the absence of a mythic, romantic symbol in its heavens, subtly reinforcing a culture that looks to cold fact, not celestial poetry, for guidance. Every trait of the planet builds the Vulcan character. A harsh world breeds resilient people. A thin atmosphere under a bright sun explains their inner eyelid, a nictitating membrane to protect against glare. Higher gravity justifies their physical endurance. The desert environment, where resources are precious and cooperation is essential for survival, becomes the perfect crucible for a philosophy that suppresses chaotic individualism in favor of logical, communal sustainability. The world did not just house the Vulcans, it designed them. This careful cause and effect world building is what makes the fictional Vulcan feel so hauntingly real. A planet with a clear, brutal logic of its own, a direct mirror to the people who walk its sands. This cultural framework was forged in fire, born from a planetary cataclysm known as the Time of Awakening. Long before they became philosophers of logic, the Vulcans were a species torn apart by their own passions. Their history tells of an era of endless, devastating wars, conflicts so brutal they nearly rendered the species extinct. Violence was not merely a tool of politics, it was an expression of their very nature, a wildfire of emotion that consumed everything it touched. The world of crimson deserts ran red with more than just iron dust. In this crucible of self-annihilation, a philosopher named Serac emerged. He did not offer a new weapon or a grand alliance. He offered a radical, terrifying idea: salvation through suppression. Serac taught that emotion itself was the enemy, an irrational, chaotic force that led to violence, prejudice, and destruction. The only path to peace, to survival as a civilization, was to master these inner storms through rigorous mental discipline, to embrace a philosophy of pure, uncompromising logic. This was not a gentle suggestion, it was a societal revolution. His followers, adopting the ways of logic, began to turn the tide not with armies, but with reason, disarming conflicts through debate and demonstrating the sheer survival advantage of cool-headed cooperation. The old ways, the violent passions, were not simply discouraged, they were systematically purged from Vulcan society, locked away behind mental barriers built over generations of training. This became the foundation of everything: their government, their science, their art, and their interpersonal relationships. Every Vulcan child is taught the mental techniques to control their biological heritage, to analyze rather than feel, to seek the most logical solution above the most satisfying one. It is a culture that views emotion with the same wary respect we might view a contained fusion reactor. A tremendous source of power that is far too dangerous to let run free. Yet biology is a stubborn architect. The most famous and challenging exception to this logical control is the pon farr, a physiological mating cycle Vulcans undergo every 7 years. This is not an emotion, it is a deep genetic imperative, a fever that overrides all conscious control and demands resolution. To ignore it is to die. The pon farr is a powerful narrative device because it represents the ultimate vulnerability, a crack in the perfect logical facade that reminds every Vulcan and the audience of the primal forces still churning beneath the surface. It is a periodic reminder that their logic is a magnificent, hard-won achievement, not a natural state. The highest expression of this philosophical journey is the collinar, a final ritual of purgation. Those who undertake collinar seek to erase every last remnant of emotion, to achieve a state of pure, uncontaminated logic. It is the ultimate mastery, the shedding of the last ties to their turbulent past. For Spock, his attempt to complete collinar became a defining character moment, a struggle between his human half, which valued the messy beauty of feeling, and his Vulcan half, which sought the serene clarity of absolute logic. His ultimate failure to complete the ritual is in fact his greatest triumph as a character. It is this constant internal struggle that makes Vulcans, and Spock in particular, so profoundly compelling. They are not robots, they are not cold. They are a species of immense passion who have chosen to build a cathedral of reason over a volcano of feeling. Every measured word, every raised eyebrow, every instance of suppressed surprise is a victory in a lifelong battle. We see the effort, we sense the cost, and that is why their moments of very rare, very controlled emotional expression, a subtle hint of friendship, a flicker of paternal pride, carry such incredible weight. Their philosophy is not about having no emotions, it is about the monumental discipline of choosing not to be ruled by them, a daily, conscious act of civilizing the self. Their biology is the ultimate expression of a world shaped by fire and logic. To survive on a harsh, desert planet with a thin atmosphere and punishing gravity, Vulcans evolved a suite of remarkable physiological adaptations, each one a testament to the brutal efficiency of evolution. The most visually striking of these is their green blood, a direct result of its unique chemistry. Unlike human blood, which is iron-based and red, Vulcan blood uses copper as the oxygen-carrying molecule, a compound called hemocyanin. When oxygenated, hemocyanin turns a distinct shade of blue-green. This is not a random choice. Copper-based blood is actually more efficient at binding and releasing oxygen in low-oxygen environments like the thin air of Vulcan. It is a perfect adaptation, allowing their bodies to extract every possible molecule of breathable air from their sparse atmosphere, a vital advantage for a species evolving under a relentless sun. This green blood is more than just a colorful quirk. It is the literal life force of a desert people, a flowing testament to their world's demanding conditions. This environmental pressure forged more than just their blood. It shaped their very nervous system, granting them abilities that seem like magic but are rooted in a logical, biological framework. The Vulcan capacity for telepathy, most famously expressed through the mind meld, is presented not as a supernatural power, but as a sophisticated form of touch telepathy, a deep neurological interface. By placing their fingers on specific psi points on another's face, a Vulcan can create a resonant link between two minds, sharing thoughts, memories, and even experiences. This ability, while profound, is treated with great solemnity and strict ethical codes within their culture, for it represents the ultimate violation and the ultimate connection. It is a tool for truth, for healing, and for preserving knowledge in its purest form. This concept extends even beyond death in the form of the katra, the living essence of a Vulcan's consciousness and memories. A Vulcan can, with great effort, transfer their katra into another being for safekeeping, a practice that blurs the line between biology and soul, suggesting a level of mental discipline so advanced it can temporarily defy the dissolution of the self. These telepathic traits hint at an evolutionary path where communication and communal survival may have been so critical that minds developed direct links, perhaps as a more efficient means of cooperation in a landscape where mere survival demanded perfect unity. Physical prowess was equally essential on a high-gravity world of rock and sand. Vulcans possess strength, endurance, and reflexes that far surpass human norms, a simple necessity for thriving in an environment that would crush a less resilient species. But their most iconic physical expression is not raw power, it is precise control, perfectly embodied by the Vulcan nerve pinch. With a swift, targeted pressure to a cluster of nerves at the base of a humanoid neck, a Vulcan can render an opponent unconscious almost instantly. The effectiveness of this technique relies on an intimate knowledge of neuropressure points and the physical strength to exploit them. It is the martial expression of their entire philosophy, a defensive action that subdues without permanent injury, that uses minimal force for maximum effect. It is logic made physical, resolving conflict with elegant efficiency rather than messy brutality. Every aspect of Vulcan biology, from their copper blood to their telepathic synapses to their reinforced musculature, tells the same story, a story of a species honed by a merciless environment into a model of survival through superior function. They are not magical beings, they are the meticulously crafted product of a world that offered no second chances, where every advantage, physiological or philosophical, was the difference between life and extinction. This philosophy of disciplined function is etched into every piece of Vulcan technology. Their innovations are not mere tools, they are physical manifestations of their worldview, where every design choice is a logical solution to a defined problem. You can see it in the very shape of their starships. Unlike the robust, multi-purpose vessels of Starfleet, which often carry the aesthetic of a floating city or a naval cruiser, Vulcan ships like the Asatron class are studies in minimalist efficiency. They are sleek with smooth, geometric lines and a distinctive ring like warp drive. There are no unnecessary protrusions, no exposed plating that suggests hasty repair. The design speaks of aerodynamic grace and perfect balance, a machine built not for a show of force, but for elegant, long-duration travel through the void. This reflects a core difference in approach. Where Starfleet engineering often embraces a certain rugged adaptability, a willingness to jury-rig systems in a crisis, Vulcan technology prizes flawless, predictable operation from the start. A human engineer might see a plasma conduit as something that can be patched. A Vulcan engineer would see the statistical probability of that conduit failing as an unacceptable flaw in the initial design logic, one that must be eliminated entirely. Their advancements are therefore most profound in fields where precision and theoretical purity yield the greatest rewards. In subspace physics, Vulcan mathematicians were instrumental in refining the very equations that make faster-than-light travel a reliable science, treating the chaotic realm of subspace with a logician's calm. Their medical technology is legendary, capable of cellular regeneration and intricate neurological repair that borders on the miraculous, yet it is always administered with a diagnostician's detached precision, viewing the body as a complex system to be restored to optimal function. Perhaps their most fundamental contribution is to computational theory. The Vulcan brain itself, with its immense capacity for parallel processing and logical deduction, served as the ultimate blueprint. They did not just build faster computers, they pioneered entire new architectures of information logic, systems that could evaluate millions of variables simultaneously to arrive at the single most statistically probable outcome. This is not artificial intelligence as humans often imagine it, with quirks and emergent personality. A Vulcan computer is the opposite, a perfect mirror of its creators, utterly devoid of intuition or guesswork, a crystal-clear pool of pure calculation. The contrast is most telling when you place a Starfleet engineering bay beside a Vulcan science station. One hums with a chorus of different sounds, consoles blinking with customized interfaces, panels occasionally sparking under strain. The other is a place of near silence, illuminated by soft, ambient light, with interfaces that respond to the lightest touch, displaying streams of data in serene, orderly patterns. The human approach builds technology that can endure, adapt, and overcome. The Vulcan approach builds technology that, in its ideal form, should never need to. It is the dream of perfect order made real, a universe where every problem has already been solved by the relentless, beautiful machinery of logic. The relationship between Vulcan and humanity began not with a handshake, but with a silent observation from orbit. In the aftermath of Earth's Third World War, a Vulcan survey ship detected the warp signature of humanity's first faster-than-light flight, Zephram Cochrane's Phoenix. They followed the signal to a world still smoldering from nuclear conflict, its people fractured and traumatized. The Vulcans made first contact, but it was a cautious, measured approach. To a humanity desperate for hope and eager to sprint into the stars, this restraint felt like a deliberate break. The Vulcans offered guidance, technology, and a framework for interstellar diplomacy, but they doled it out slowly, insisting humanity must first achieve social and political unity, must mature. For a species bursting with post-war optimism and raw ambition, this careful oversight felt less like mentorship and more like a patronizing lecture from a distant, disapproving parent. The decades that followed were a simmering tension between profound gratitude and simmering resentment. Humans were the emotional adolescents of the galaxy, passionate, creative, and dangerously impulsive. The Vulcans were the mature, logical adults advocating for patience, risk assessment, and lengthy deliberation. Every human request for a faster warp drive or a more advanced weapon system was met with a Vulcan reminder about cultural readiness and the perils of unchecked advancement. This dynamic created a foundational friction. From the human perspective, the Vulcans were holding them back, gatekeeping the galaxy out of a sense of superiority or perhaps fear of a new rival. From the Vulcan perspective, they were preventing a volatile, war-scarred species from repeating its mistakes on an interstellar scale, a logical duty to preserve galactic stability. The relationship was a constant push and pull. A key moment of crisis came with the founding of the United Federation of Planets. It was not a foregone conclusion. Many within the Vulcan High Command argued against joining, viewing the proposed coalition, especially with humans at its heart, as an unstable emotional experiment. They advocated for continued isolation or a Vulcan-led alliance with more predictable, logical species. It took a seismic shift, a rediscovery of their own forgotten emotional history, and the intervention of a time-traveling human to convince the Vulcan leadership to change course. Their decision to join the Federation was not an embrace of human emotion, but a logical calculation that the potential benefits of diverse cooperation now outweighed the risks. Even within the Federation, the dynamic persisted. Humans, with their notorious intuition and gut feelings, would often charge into situations that Vulcan analysis deemed hopeless or ill-advised. And sometimes, against all logic, the humans would succeed, pulling victory from the jaws of disaster through sheer stubbornness and compassion. These incidents were deeply confounding to the Vulcan mind, an unpredictable variable that challenged the very foundations of their predictive models. Yet, this friction was also the source of their greatest strength. The Federation did not become a homogenized bloc, it became a symbiotic partnership. Human passion provided the drive and the moral compass, the insistence that some risks were worth taking for the right reasons. Vulcan logic provided the necessary checks and balances, the rigorous analysis that prevented good intentions from spiraling into catastrophe. They tempered each other's extremes. A starship crewed by both species, like the legendary Enterprise, became a microcosm of this ideal. A place where Spock's logic and Captain Kirk's intuition were not in opposition, but in dialogue, each proving the other's value in turn. The alliance was fraught, but it was precisely this tension that forged something stronger than either species could have built alone. A union where logic gave compassion its direction, and compassion gave logic its heart. The richness of Vulcan culture is revealed through more than just its most famous son. Other characters have explored the nuances and fractures within this logical society, showing it is far from monolithic. Take Commander T'Pol, the Vulcan science officer assigned to Earth's first deep space starship, the Enterprise NX-01. Her story is a masterclass in cultural friction. When she first steps aboard, she is the embodiment of Vulcan oversight, a living reminder to Captain Archer and his crew of their inexperience. Her every interaction is laced with polite disdain, her logic a constant critique of human impulsiveness. She views their emotional reactions as a dangerous liability, their curiosity as recklessness. Yet, stranded for light years from Vulcan authority, something profound happens. The rigid shell of her upbringing begins to crack under the relentless pressure of human companionship and the bizarre realities of deep space exploration. We see her struggle with a previously undiagnosed neurological condition that heightens her emotions, forcing her to confront the very biology her culture denies. Her slow, grudging respect for Archer, her growing, illogical loyalty to the crew, and her eventual embrace of a more flexible path make her arc one of the most compelling portraits of change. T'Pol represents the first generation of Vulcans to truly live with humanity, not just observe them, and her personal journey mirrors the painful, necessary thaw in relations between the two species. In stark contrast stands Tuvok, the tactical officer aboard the USS Voyager, lost in the distant Delta Quadrant. By the 24th century, Vulcans in Starfleet are no longer a novelty, and Tuvok is the model of a fully integrated officer. He is not there to supervise humans, but to serve alongside them as a peer. His logic is not a barrier, but a professional asset, a cool head in countless crises. Yet, even Tuvok's impeccable control has its limits and its depths. We see the immense strain his logic is under, being separated from his family for what could be a lifetime, surrounded by the often chaotic emotional output of his crewmates, particularly the irrepressible Tom Paris. His long friendship with Captain Janeway is built on mutual respect, not on overcoming prejudice, showing how far the relationship has evolved. Tuvok also provides glimpses into Vulcan domestic life through his flashbacks, revealing a culture of quiet ritual, profound familial bonds expressed through action rather than sentiment, and the immense private discipline required to maintain his public composure. He is the logical ideal in action, proving that Vulcan philosophy can be a sustaining force, not just a restraining one, even in the most isolating circumstances imaginable. But logic can also lead down darker paths when it becomes rigid or corrupted. Lieutenant Valeris, the Vulcan protege in Star Trek VI, represents a tragic perversion of the ideal. As a young, brilliant officer, she embodies a cold, mathematical logic taken to a horrifying extreme. She participates in a conspiracy to assassinate the Federation president and sabotage peace talks with the Klingons, not out of hatred, but out of a calculated belief that peace is illogical and that the Federation's survival demands continued conflict. Her logic, divorced from any ethical foundation or empathy, becomes a weapon. She is the warning, the embodiment of Surak's fear that pure reason without a moral compass can justify any atrocity. Similarly, the Vulcan Science Directorate, mentioned in various episodes, sometimes represents institutional arrogance. Their famous declaration that time travel is impossible, despite mounting evidence to the contrary, shows how logic can calcify into dogma, how a commitment to proven facts can blind an institution to new discoveries. These examples are crucial. They demonstrate that Vulcans are not infallible. Their logic can be misapplied, their institutions can become stagnant, and individuals can use reason to justify profound evil. This complexity prevents them from being mere paragons. They remain a people capable of greatness and failure, their philosophy a tool that is only as good as the hands and the heart that wield it. The fictional world of Vulcan did not stop evolving when the cameras turned off. Beyond the filmed episodes and movies, a vast constellation of expanded lore has grown in novels, video games, and the boundless realm of fan speculation, adding layers of rock and sand to its crimson deserts. Licensed novels have been particularly fertile ground, acting as archaeological expeditions into Vulcan's distant past and intricate present. They have given names and histories to its stark geography. We can now visualize the immense, desolate region known as the Forge, a deadly expanse of radioactive plains and jagged rock where only the hardiest survive, and which serves as the ultimate proving ground for Vulcan endurance. We have journeyed to Mount Selaya, the sacred mountain where the ritual of Fal Torpan, the refusion of a Katra with a body, was performed, its peaks shrouded in myth and telepathic resonance. These stories have delved into the complex, often tense politics of the Vulcan High Command and the Cyrenite reform movement, showing a society where logical debate can be as fierce and consequential as any war. Video games have offered a different kind of immersion, allowing players to walk those sands firsthand. In expansive titles, you can pilot a shuttle over the ochre skies of Vulcan, navigate the treacherous canyons of the Forge on foot, or stand in the hallowed halls of the Vulcan Science Academy. This interactive exploration makes the planet tangible in a way passive viewing cannot, letting you feel the scale of its deserts and the imposing silence of its ancient temples. Through gameplay and storylines, these games have woven new threads into Vulcan history, depicting ancient wars against cybernetic invaders or secret archaeological digs that uncover relics from the time before Serac, further fleshing out the planet's deep, layered chronology. Perhaps the most creative expansions come from the fans themselves, who have spun intricate theories connecting Vulcan dots across the galaxy. One persistent idea links the Vulcans and their offshoot cousins, the Romulans, to ancient human mythology. The theory notes that the Romulan homeworlds are named Romulus and Remus after the legendary twin founders of Rome. Could this be more than a coincidence? Some speculate that a pre-logic Vulcan expedition, or perhaps even a group of early Romulan exiles, might have visited Earth in antiquity, inspiring the myth. It is a tantalizing thought that the fierce, passionate Romulans could have been the seed for stories of warlike gods, while the disciplined, logical Vulcans inspired tales of Stoic philosophers. This naturally leads to deeper speculation about the Romulans themselves. Canon tells us they are an offshoot of the Vulcan species, a group that rejected Serac's teachings of logic and fled their homeworld long ago. But fan theories love to explore the nuances of that schism. Were the Romulans simply those who valued emotion and freedom over control, or was their exodus driven by a fundamental biological difference that made them unable or unwilling to suppress their passions? Some theories ponder if the Romulan capacity for extreme secrecy and duplicity is not just a cultural choice, but an evolutionary adaptation for survival, a different kind of logic born from perpetual paranoia. Others explore the reverse idea, questioning whether mainstream Vulcans, in their pursuit of pure logic, have inadvertently stunted another potential evolutionary path, one that beautifully integrates emotion and reason rather than segregating them. These discussions have no official answer, which is their power. They keep the world alive, dynamic, and endlessly debatable, proving that the most enduring fictional creations are not those that give all the answers, but those that inspire the best questions. Every logical society carries the shadow of what it chose to leave behind. For the Vulcans, that shadow has a name and a formidable empire. The Romulans are not merely alien adversaries, they are a living mirror, a reflection of the path not taken. Their origin story is one of the most profound schisms in galactic history. Centuries after Serac's reformation, as logic solidified into doctrine, a significant faction found the new ways intolerable. These were Vulcans who saw emotion not as a chaos to be suppressed, but as a vital source of strength, identity, and freedom. They refused to lock away their passions, viewing the discipline of logic as a form of cultural suicide, a slow death of the spirit. The conflict that followed was not a war of weapons, but a war of souls. Unable to coexist, the traditionalists, those who would become the Romulans, made a desperate choice. They gathered their ships and fled their homeworld forever, embarking on a long, perilous exodus into the uncharted stars. They eventually settled on the twin planets Romulus and Remus, named for the mythic founders of Rome, and there they built something entirely new, a society forged from the very emotions their cousins had vowed to erase. The Romulan star empire became Vulcan's polar opposite. Where Vulcan culture is open in its philosophical debates, Romulan society is shrouded in layers of secrecy and suspicion. Their government, the Tal Shire, is not just an intelligence agency, it is the central nervous system of the state, monitoring every citizen for disloyalty. This paranoia is a logical outcome of their founding trauma, a deep-seated fear that without absolute control, their hard-won emotional freedom could spiral back into the destructive chaos that once plagued Vulcan. Passion for the Romulans must be channeled into nationalistic fervor and imperial ambition, lest it turn inward and tear their society apart. Their aesthetic reflects this duality. Vulcan architecture is minimalist, geometric, blending with the desert. Romulan design is grandiose, imposing, with sharp angles and dark, gleaming materials meant to inspire awe and intimidation. A Vulcan speaks with measured precision, a Romulan with layered nuance and implication, where what is left unsaid is often more important than the words themselves. This schism creates endless dramatic tension. Every encounter between a Vulcan and a Romulan is charged with this ancient, unspoken history. They see in each other a hauntingly familiar face, twisted by a different choice. The Vulcan looks at the Romulan and sees the violent, untamed ancestor they worked for millennia to civilize. The Romulan looks at the Vulcan and sees a hollowed-out sibling, a ghost who traded fire for frost, believing they had mastered their nature when they had only buried it alive. This dynamic explores profound themes of duality and repression. The two species represent the eternal struggle between the head and the heart, between control and expression. The Vulcans ask, can we truly be civilized if we are slaves to our feelings? The Romulans counter, can we truly be alive if we are prisoners of our thoughts? The drama lies in the possibility that both might be right and both might be wrong. It suggests that the health of a psyche or a civilization may not lie in choosing one extreme over the other, but in finding a precarious, honest balance. The Romulans stand as a permanent reminder to the Vulcans of the raw power they suppressed, a power that is dangerous, yes, but also a source of creativity, courage, and profound connection. They are the unquiet ghost of Vulcan's past, a whispered question that logic can never fully silence. What was the true cost of their perfect peace? The crimson deserts of Vulcan remain a fiction, but the profound question it represents is now a driving force of modern science. Today's astronomers are engaged in a hunt far grander than Leverrier could have dreamed, not for a phantom in our own solar system, but for solid, verifiable worlds orbiting distant suns. We call them exoplanets, and finding them has transformed our understanding of the cosmos from a collection of lonely stars into a galaxy teeming with potential. The search has moved from the blinding glare around our sun to the deep, star-filled darkness, seeking not a missing gear in a clockwork, but entirely new clocks of their own. The ultimate goal, the silent hope behind every observation, is to find a world that echoes the most compelling aspects of that fictional forge, a rocky planet orbiting within its star's habitable zone, where conditions might just be right for life to arise. This habitable zone, often poetically called the Goldilocks zone, is the orbital region where a planet is neither too hot nor too cold for liquid water to exist on its surface. It is not a guarantee of life, but it is the most fundamental prerequisite we know. A world in this zone around a stable, sun-like star becomes an instant candidate for deeper study, a potential exo-Vulcan in the making. The methods used to find these distant specks are feats of ingenuity that make the 19th century transit hunts look like squinting through a keyhole. Two primary techniques have yielded thousands of discoveries. The first is the transit method used by spacecraft like Kepler and TESS. Imagine watching a distant street lamp at night. If a moth flies directly between you and the bulb, the light dims ever so slightly. A planet transiting its star does the same thing. By monitoring the brightness of hundreds of thousands of stars with incredible precision, astronomers can detect the telltale, periodic dip in light caused by an orbiting world crossing the star's face. This not only confirms the planet's existence but can reveal its size and orbital period. The second key technique is radial velocity, or the wobble method. This is a direct descendant of the logic that led to Vulcan and Neptune, but executed with laser precision. A star and its planets orbit a common center of mass. A large planet does not simply go around a motionless star, it tugs on it, causing the star to wobble in a tiny, rhythmic dance. By analyzing the star's light, scientists can detect the subtle shifts in its color as it wobbles toward us and then away, revealing the planet's gravitational influence, its mass, and the length of its year. Together, these methods paint a portrait of distant solar systems. We have found hot Jupiters, giant planets blistering close to their stars, and super-Earths, rocky worlds larger than our own. And among them are the most tantalizing finds, Earth-sized planets orbiting within that temperate Goldilocks zone of calm, long-lived stars. Worlds with names like Kepler 452b or the planets in the TRAPPIST-1 system are not Vulcan, but they fulfill the first, most critical step of the old dream, a stable, rocky world in the right place. The fictional Vulcan, with its humanoid inhabitants and complex culture, serves as a powerful narrative template for this scientific hope. It embodies our deepest curiosity, the question of whether the universe is not only habitable but inhabited, and whether that life could ever resemble us in mind or form. Every newly confirmed exoplanet in the habitable zone is a data point in that grand inquiry. We cannot yet see their surfaces, sense their atmospheres, or detect the signatures of cities or chlorophyll. But the hunt has shifted from if such worlds exist to how many there are and what they are made of. The next generation of telescopes, like the James Webb Space Telescope, aims to peer at the light filtering through the atmospheres of these distant worlds, looking for chemical biosignatures, the molecular fingerprints of possible life, such as oxygen, methane, or water vapor. We are searching, in essence, for a world that forces us to update our story once again, not by explaining away an orbital anomaly, but by answering the oldest question of all. Are we alone? The ghost of a planet that never was continues to guide us, its legacy no longer a cautionary tale of error, but a beacon for the greatest discovery still to come. Vulcan's power lies in its haunting duality, a perfect collision of fact and fantasy. It is both a cautionary tale from the annals of science and a foundational myth for our dreams of tomorrow. This enduring appeal speaks to something deep within us, a collective fascination with the world that never was. We are drawn to lost cities, sunken continents, and hidden planets because they represent the ultimate mystery, a blank space on the map where our imagination can run free. Vulcan is the quintessential scientific detective story, a puzzle that consumed brilliant minds for decades, filled with dramatic sightings, bitter rivalries, and a final, shocking twist that rewrote the laws of physics. It satisfies our craving for intellectual drama, where the stakes are nothing less than the true nature of the universe, but the story does not end with a correction in a textbook. It seamlessly transforms into a profound philosophical thought experiment. What if a species chose logic over emotion? What would that society look like? How would it function? The fictional Vulcan provides a stage to explore these questions in vivid detail, letting us walk its deserts and debate its principles through characters who feel both alien and deeply relatable. It becomes a mirror reflecting our own struggles between reason and passion, between the cool analysis of the mind and the warm impulse of the heart. We see the immense discipline required for such control, and we also see the cost, the hidden vulnerabilities like the pon farr that remind us biology cannot be fully denied. This is not just world building, it is soul building, constructing an entire ethos that challenges us to examine our own. Ultimately, Vulcan endures because it is a story of aspiration. The real hunt was an aspiration to complete our cosmic model, to make the universe perfectly knowable. Its failure led to an even greater aspiration to understand a deeper, more beautiful truth. The fictional incarnation aspires to show us a better version of ourselves, or at least a different one, a society that has conquered its inner chaos to reach for the stars with clear, purposeful intent. It gives us the mythos for a hopeful future, one where diverse species like humans and Vulcans can bridge their differences to achieve something neither could alone. Vulcan, in all its forms, exists at that rare intersection where a glorious era fuels the imagination, which in turn fuels our highest aspirations. It is the ghost that taught us to see the curvature of space, and the legend that taught us to value the logic in our minds and the humanity in our hearts. The world that never was, in the end, helped us build a richer understanding of the world that is, and the countless worlds that might yet be. The story of Vulcan offers more than a curious footnote in astronomy or a beloved science fiction setting. It provides a powerful blueprint for how we navigate uncertainty, both in our laboratories and in our communities. For science, the long-failed hunt is not a tale of shame, but a masterclass in progress. It demonstrates that even our most elegant and successful theories are not permanent cathedrals, but temporary shelters, always subject to the weather of new evidence. Newtonian physics was arguably the most successful scientific framework ever devised, predicting the motions of the heavens with breathtaking accuracy for centuries. Yet its very perfection became a trap. When Mercury's orbit refused to conform, the only logical solution within that system was to invent a new planet. Scientists spent decades searching for that planet because the alternative was unthinkable, questioning gravity itself. This shows us that scientific revolutions rarely begin with someone shouting that everything we know is wrong. They begin with a quiet, persistent anomaly that refuses to go away, a single piece of data that does not fit the beautiful puzzle. The true breakthrough came not from finding the expected answer, but from having the courage to discard the question entirely and ask a new one. What if gravity works differently than we thought? Einstein's genius was not in fixing Newton's clockwork, but in realizing it was the wrong kind of clock altogether. The lesson is profound. Our greatest advances often spring from our most elegant failures. A dead end, thoroughly explored and proven impassable, clears the mental landscape, forcing a radical change in direction. Vulcan's ghost had to be fully exorcised by observation before the deeper truth of curved spacetime could be accepted. This is the essential, humbling process of science, where being proven wrong is not a defeat, but the very engine of discovery. This same narrative offers a compelling allegory for our own societal challenges here on Earth. The fraught, decades-long relationship between Vulcans and humans mirrors the difficult but essential work of international diplomacy and deep cultural exchange. Initially, the two species viewed each other with a mixture of awe and deep suspicion. Humans saw the Vulcans as arrogant gatekeepers, withholding technology out of a sense of superiority. The Vulcans saw humanity as a volatile, emotional child, recently recovered from global war and unfit for the responsibilities of the stars. Their interactions were a tense dance of misunderstanding, where each side's greatest strengths were perceived by the other as dangerous flaws. This is not so different from real-world first contacts between civilizations, or even the ongoing negotiations between modern nations with vastly different histories, values, and priorities. The instinct is often to impose one's own worldview, to see difference as a deficit to be corrected. The Vulcan approach of measured, cautious mentorship, while frustrating to the eager humans, was rooted in a logical assessment of risk, a desire to prevent a new power from repeating old, catastrophic mistakes. The human impulse to rush forward, to connect and explore with passionate curiosity, was equally valid as a driver of growth. The friction between these worldviews, between cool logic and warm passion, is the central drama of their alliance. It is the same friction we experience when integrating different cultures, business practices, or political systems. One side values data and precedent, the other values intuition and innovation. The easy path is to retreat into one's own camp, to dismiss the other as illogical or irrational. But the story of the Federation shows us the harder, more rewarding path. The ultimate strength of the United Federation of Planets did not come from the Vulcans convincing everyone to be logical, or from the humans infecting everyone with emotion. It came from synthesis. It came from creating a space where Spock's logic and Kirk's intuition were in constant dialogue, where each could check the other's excesses. A starship commanded by both a Vulcan science officer and a human captain became greater than the sum of its parts. The logic provided a crucial safeguard against reckless action, while the human compassion provided a moral compass that pure logic sometimes lacks. This is the hopeful model for our own global society. The goal is not a bland, homogenized world culture where everyone thinks the same. The goal is a framework like the Federation's Charter that allows for profound difference while establishing shared principles of cooperation, mutual respect, and common purpose. The Vulcan human allegory teaches us that the most resilient and creative systems are built from tension, not from uniformity. It is in the respectful collision of different worldviews, logic and emotion, caution and courage, analysis and artistry, that we find solutions to problems that neither side could solve alone. The ghost of a planet that never was and the fictional world it inspired ultimately point us toward this stellar aspiration to build a future where our differences are not walls, but the very architecture of a stronger, shared home. So the question becomes not just about Vulcan, but about you. If you were given a blank star chart and the power to design a world, what philosophy would shape its civilization? Would you build a society of pure logic, a utopia where every decision is optimized and conflict is solved through calm debate? Or would you lean into emotion, creating a culture that values artistic expression and passionate connection above all else? Perhaps your ideal world finds a third path, a delicate balance where reason and feeling are not at war, but in constant creative conversation. Is a purely logical society even possible for beings born with a heartbeat, or is it a beautiful, impossible dream? We have seen the immense discipline it requires and the hidden costs. What do you think? Is that trade-off worth it? Beyond the grand ideas, this story lives in its moments. Was it Spock's final, whispered, "I have been and always shall be your friend," or the fierce loyalty of T'Pol defying her own government for a human crew? Maybe it's the quiet intensity of Tuvok's loyalty or the shocking logic of Valoris's betrayal. These characters give the philosophy a face and a heart. So tell us in the comments, what is your favorite Vulcan moment or the character that made you see logic in a new light? This conversation has spanned from a mathematical error to a galactic federation, from a phantom in the data to a people who live in our collective imagination. Now we pass the scanner to you. What worlds will you imagine? From a phantom tugging at Mercury's orbit to a cornerstone of science fiction, Vulcan's journey is a testament to the human mind's relentless curiosity. It began with Urbain Le Verrier, a genius so confident in Newton's clockwork universe that he used a tiny orbital anomaly to predict a new world. For decades, that prediction felt like destiny, sending astronomers on a grand hunt that sharpened their tools and their skepticism to a fine edge. The failure to find that world, however, was not an end. It was the essential pressure that cracked the old model wide open, allowing Albert Einstein to step through with a vision of gravity not as a force, but as the curvature of spacetime itself. In a beautiful twist, the ghost planet's greatest contribution was its absence, making Mercury's wobble the perfect proof for a revolutionary idea. The story could have ended there, a fascinating footnote in the history of physics. But names have power, and Vulcan was too potent to fade into obscurity. It was resurrected in the pulps and comics, a ready-made world of fire and mystery, before Gene Roddenberry performed his final act of alchemy. He took the residue of a scientific error and forged it into the homeworld of Mr. Spock, transforming a mathematical placeholder into a philosophical ideal. Vulcan became a culture, a biology, a set of ethics, a mirror held up to our own struggle between logic and emotion. This single concept, born from a mistake, taught us more about the scientific process, the power of narrative, and the depths of our own aspirations than many solid, real discoveries ever could. It showed us that being gloriously wrong can be the first step toward being profoundly right, and that our greatest stories often grow from the fertile soil of our unanswered questions. Today, the search continues on two fronts. Telescopes like James Webb scan the atmospheres of distant exoplanets, seeking the chemical signatures of life on real worlds in Goldilocks zones. And in our minds, we keep designing new civilizations, asking what forms life and society could take on worlds of ice or gas or endless ocean. The legacy of Vulcan is this dual quest, a reminder that exploring the universe and exploring the human condition are the same magnificent endeavor. We are all still searching for the world that never was, and in that search we discover who we are and who we might yet become. For more journeys to the edges of science and the frontiers of imagination, be sure to subscribe.